Thank you so much, ladies and gentlemen, for joining ETAuto Roundtable series on R&D and manufacturing in automotive industry. I'm so sorry, extremely sorry for the delay due to some technical glitch, and to the panel member for joining in at ETAuto Roundtable discussion on electric vehicle and its subsystem. What are the challenges that has come up in the outbreak of COVID-19? How are we trying to cope up with the various business segment of electric vehicle in Indian market and overseas? Talking about the value chains such as technology, talking about the battery management system, or we are talking about thermal efficiency, or we are talking about powertrain, or we are electric powertrain. How different is it going to be compared to internal combustion engine? That's the topic that we're going to discuss today. I would also let me introduce to you today's panel that we have here Amitabh Saran, who is co-founder of Altigreen, which is a startup trying to help the electric mobility value chain by providing equally potent, powertrain systems. And they are also into two-wheeler and three-wheeler or last mile connectivity solution in electric vehicle. We are also joined by Suresh D, who is the CTO, Chief Technology Officer at Spark Minda Group, and he's also CEO of Minda Technical Center. We are also joined by Mani Prithvi from Siemens Digital Digital Technology Industry, Siemens Digital Technology. And we are also joined by Mr. Pradeep Kumar, who is Apollo Tyres Head of R&D, Global Head of R&D. I'm also lucky to joined by Mr. Roger Looney, who is Vice President at Ola Vehicle Engineering. So we have a complete panel today that we have. Thank you so much, gentlemen, for joining ETAuto. Thank you so much, everyone, for staying with us. I'm sorry about the technical glitch, and due to which we got a bit late. Let's begin this session with a quick remark from every one of you for 2 minutes. Like, what are your initial thoughts when it comes to electric values system or design and development of electric vehicles or its subsystems? I'll start with Suresh, because in the supply side, we do not have really many suppliers for electric vehicles in India. How do you see the scene changing, and what are the challenges you see when it comes to electric vehicle supply and subsystems development and design?
Thank you, Nabil. When it comes to the EV, we know that the three challenges which are always in front of us. One is the power, second is the range, third is the price of the vehicle. Yeah. Now, as a component guy and a EV OEM manufacturer, they have to give us solutions to the end user. The total cost of ownership of the vehicle should attract the end user so that the end user can willing to buy a EV vehicle. Now, when it comes to India, the biggest challenge is that India is moving into BS4 to BS6 very, very recently. Yeah, a lot of OEMs have focused their efforts and investments towards the powertrain, the conventional powertrain, the ICE, internal combustion engine. These investments are not small because it's huge investments, I can say, in terms of people, competency, infrastructure, getting the vehicle platform ready, and so on. Now, another change from internal combustion engine to EV is a big change. Yeah, a transformation. Instead of change, I would say transformation. So this transformation has to be, cope up by the OEMs and also the component guys. Yeah. Now, for OEM, the set of challenges are different. For a component guy, the challenges are different. Let me talk on the component side. For a component, the ecosystem is a challenge. You have to get the talent, manpower. The different sets of components which are required for EV, which are new. For example, you have a traditional components and non-traditional components. For example, a battery and BMS is non-traditional. A power electronic solutions is non-traditional. Cooling systems which are required for a EV is non-traditional. So these are some of the challenges in front of the component guy. Similar way, integration is a challenge. Meeting the norms, EMI, EMC is a challenge. Meeting the range is a challenge. Performance is a challenge. So lots of challenges in front, but obviously challenges can always bring a solution. So yeah, that would be the my starting statement. Let's discuss further.
Amitabh, powertrain is one of the biggest challenge when you compare with power performance of the vehicle is seen as the biggest hindrance for anybody who want to adopt electric vehicles. How can you convince the customers that electric vehicles can equally be as powerful as ICE engines? What are the technology? Looking at the cost competitiveness of the market like India, where people have a limited dispensable income, they can spend limited amount of money. If you look at the vehicles, that kind of vehicles coming in EVs up to 10,000 rupees, 10 lakh rupees, you have passenger vehicles available. In such a scenario, how can you convince of equal power performance of the powertrain?
Well, thank you, Nabil. Hi, everyone. So I think it's a fairly broad question. I'll try to do justice to it. I don't think there's any short answer to this, unfortunately. It does require a very keen understanding of the problem that we're trying to address, and for that, it might require a complete redesign, fabrication, testing, manufacturing for the needs of a specific geography. So, like you said, for India, we may have to, and we will likely have to design to the specific needs of that. And when you're doing design, manufacturability, serviceability, cost of the component become important. So while you're trying to ensure that you can deliver to the price and performance of a conventional vehicle, I think all these factors need to be taken into consideration. And I think a lot of the EV industry is trying to do that. Of course, there's no doubt that startups, early stage companies are the ones that typically don't have a baggage that they carry with them. And by baggage, I mean it could be, a sunk cost bias, like Suresh was just mentioning, that you invested so much that becomes very difficult for you to kind of figure out ways by which you can avoid cannibalizing the existing business that you have. So those decisions become tough, and hence it's typically the early stage companies that either do the investment or have the capability and the wish to make that change happen. And as a company, for example, Altigreen has been doing just that. But I think that's true across the board. If you design the component right, if you manufacture the component right with the right kind of processes for the right kind of geography, you will get the price points right too. I think you just have to be cognizant of the problem that you're trying to fix, not try to fix too many problems at the same time. I think the segmentation of the market, the right fit for as a product for that market, the right segment within that market. So, for example, we strongly believe last mile transportation is a way to expedite the adoption of electric vehicles in this geography. And by this geography, I mean India and the developing world. That's our take on it, and I believe that's the only way we can go ahead and do something like that. If you expect to constantly survive on imports and hope to retrofit them and create solutions, they will either be more expensive or they will be a compromise on performance. I'm not taking any specific names of countries, but you can obviously understand who I'm talking about.
I'll just bring in, Roger here, because he is the potential biggest buyer of electric vehicles, fleet service provider. Roger is representing Ola Mobility, and he is vehicle design head there. Looking at the electric vehicles, especially after COVID, what kind of design or what kind of product do you expect to buy, Roger? And what overall, what kind of vehicle you would expect an electric vehicle in terms of design should be that will have a demand in times like these?
Well, if we work off the assumption that social distancing will be the norm for the next 2 or 3 years, which is the assumption that we're working with ETAuto currently, right? So the market will heavily skew towards, at least in shared mobility, vehicles where we can easily fit 2 people separated. Open vehicles will still remain quite popular, right? So I think 3-wheelers in particular, maybe with some added curtains and things, will be the major last mile mobility. Certainly at Ola Electric, that's what we're going to concentrate on as far as launching batteries as a service and the partners that we're signing up to use that battery as a service. So we're actually quite bullish on that market because things will start to open up. We can't all stay inside forever. So as that happens, and I think people are going to be cautious about how close they get to one another in order to stop the spread. So you can see it on the street today, not just in India, but in every country. Things have changed. The idea of personal differences already changed quite a bit out to 1 meter. And that will affect the way we use the current form factors in India and abroad as well. So for us, we're going to concentrate on those last mile form factors. We feel that 2-wheelers are going to start to take a higher precedence, not just in India, but many places abroad as well. And yeah, that's where we're concentrating. That's how we kind of see the COVID situation playing out here and abroad too.
Yeah, so before we get into a detailed discussion on thermal efficiency and battery package design or overall other parts design and development, I'll just like to bring in Pradeep Kumar from Apollo Tyres. When it comes to ICE engine, we focus a lot on the efficiency being driven by tires. But so far, when we talk about electric vehicle, we have really not been focusing on tires. Pradeep, can you share an insight how important are tires when it comes to electric vehicle, when in terms of efficiency, in terms of increasing the mileage in electric vehicles, and why has not it been so important so far? Why people are not talking about that? Or is it that something that we can easily ignore in electric vehicle? Or is
Absolutely. You have brought the right point, Nabil. Hi, everyone. At Apollo Tyres, we design, develop, and manufacture pneumatic tires for all segments of the vehicle. And so far, we also complained this several times. So tires are the least recognized component in a vehicle, whereas that is the only link between the vehicle and the road. And all that you brag about your vehicle performance has to be realized through the component called tires. So anyway, this scenario will change when EVs will come up. You know, EVs pose a different set of challenges because in ICE EVs, there are many inefficiencies which are getting removed when you move into EVs. So when all these components which are getting removed, then the role of tires will come into prominence. That's what I believe. And as on today, tire industry understands fairly well what are the broad requirements EVs require. But I have my own take on this because this is evolving. In my opinion, these EVs are in the early phases of its development because the designs of ICE EVs have been optimized over the years for the IC engine mounting, transmission, and exhaust systems, etc. But if you look at EVs and ICE EVs, they look the same from the outside, whereas everything underneath is different. So I'm sure that as the technology evolves, the structure will change, the design of EVs will change to suit electric motor mounting, driveline positioning, and battery pack positioning, things like that. This change will demand new set of requirements from components such as tires. So in my opinion, this is an evolving requirement, and you are going to see much more different requirements in the future than it is at present we can see.
Thank you, Pradeep. Mani, you are a provider of technology when it comes to design and development of any product or testing of a product. Looking at the current scenario, there is is going to be huge change that is going to come in every kind of product. What is your forecast? What is your assessment of the situation? Which are the area or the way you are receiving feedback from your customers? Which are the area you see is going to change when it comes to automobiles, especially electric vehicles? And how are you trying to support? And what are the other technology companies that is available with the support that could be utilized in terms of faster adoption of the changes that would required after COVID environment? Because
Sure. Hi, everyone. Thank you, Nabil. Um, so at the outset, I'd like to point out that these are exciting times, in my opinion, for simulations. So if we briefly look at how the simulation field has evolved over the last 15 years, I would say 15 years ago, we were primarily using simulations for troubleshooting one-off instances. Then we evolved to a stage where maybe we did one baseline and then we moved on to a few modifications on top of that. Now what I see is in terms of the challenges that are coming up, there are two major challenges that are coming up. For instance, going back to what Suresh said, there are a lot of differences between conventional powertrains and electric powertrains. So the requirements are changing. Now, the good news with simulations is, if you have a simulation working, say, on thermal management, at the end of the day, it doesn't matter whether you have an electric powertrain or you have an ICE powertrain. You have an energy source, you have heat generation. And as long as you're able to capture that physics, you're able to provide answers. So during these challenging times with the COVID, what we're seeing is like not everyone is able to come to the shop floor and do the testing. So I see a big increase in the requirements for simulations. And the other change that is going to happen is because we cannot invest on each and every variation that is going to come out, we have to do a lot of virtual testing upfront. So I believe that simulation is going to play a very, very important role upfront, and especially in things like how do you strike a compromise between two competing factors. On one hand, you're trying to increase the performance of your vehicle. On the other hand, we want to make sure that the passengers in the cabin are comfortable. So when when we have to do a lot of such scenarios, this is where I think simulations are really going to help. We can study upfront a number of scenarios in terms of how things could be adjusted, and we are not going to be eliminating testing by any means, but simulation should give us good direction in terms of what are the good designs that we need to be testing before we bring it to the market. So I see a lot of opportunities from the simulation front, and as and when the topics come up, I can probably go into a little more detail. So that would be my opening statement.
thank you, Mani. I'll again bring back Amitabh here. Amitabh, when it comes to startups or largely electric vehicle, ecosystem is driven by startups. Going forward, vehicle design, body design, and prototype is going to be a very important aspect of your business, and that too, providing a prototype at a very low cost. How technology like digital design and development or simulation and testing is helping a company like you to produce multiple prototypes at a low cost, or which is a cost which is acceptable to a startups. May not be you, but there are many startups which are not very well funded. So in such a scenario, how do you see that?
Yeah, and I think Mani has said the right thing. Simulation, all kinds of computer tools will be required a lot more. I think by the very nature, electric vehicles are a lot simpler in their design and construction, and hence to be able to emulate and simulate them is definitely a slightly easier task compared to an ICE. Of course, ICE have been around for 100+ years, and hence there's a whole body of information and knowledge and understanding about them. I think same thing is true for electric vehicles. They've actually been around longer than ICE, if you really look at it. But I think the focus shifted for a good 100 years. Having said that, you're absolutely right. Lightweighting is an extremely important part of vehicle design going forward. Unfortunately, lightweighting brings with it, at this point, because of low volume, it does bring with it a slightly more expensive body. And along with that, a slight mindset change in the eyes of the customer also. Especially in the last mile transportation segment. We're talking about commercial vehicles in the last mile transportation, which I believe is the primary market for EVs. There, the concept of a metal body being the right approach as a vehicle is concerned, something that can be tinkered around. But once that mindset you get over that mindset, and it's been dealt very well in the two-wheeler space, where most of the vehicles now have panels that are either plastic or made of some kind of composite. I think going forward, most vehicles are going to be like that. Simulation is going to play a very, very key role. I think there's a lot of R&D going on in composites and in different kinds of lightweight materials. Whether it is on the body side or also on the chassis side. So I think a lot of work happening in that area. Even for components, when we make components, whether it's motors or controllers or any of the other components of a vehicle, there too, the choice of materials is an important factor in determining both the efficiency, the weight, and the overall performance of a vehicle. So I think when you put all that together, simulation becomes an important thing. Prototyping, fabrication, quick prototyping and fabrication. And that's something that you notice in some of the other developed economies, where a lot of time, at least in India, we invest a lot of time and energy in putting together that first prototype. And it's not easy. And like you rightly said, startups are the ones that push the agenda, and they're always limited for resources, both in terms of cash, in terms of manpower, and in terms of time. And hence, sometimes you have this habit or this tendency to shortcut things, which ultimately in the long run are not good. So if you do it right, there is a gestation period. We have to invest that time, and that's where simulations and these kinds of things will help dramatically in the evolution of EVs.
Thank you, Amitabh. I'll come back to you, Suresh, again. Amitabh talked about, lightweighting, and that is very important. He's talking about engineered plastic, use of engineered plastic or composites. Which are the parts you think possibly are in immediate region when you talk about reducing the weight when it comes to vehicle design? Which are the parts that you think should we target immediately, where we can immediately decrease the weight of the product or the parts? We have been doing a lot of work in the past, even in ICE engine. This has been one of the mega trends. How is it going to shape up or change with the electric vehicles?
Yeah.
For passenger vehicle, for car, for the two-wheelers and for three-wheelers, everywhere you can just give a.
Yeah. So weight reduction is a very, very important and a challenging for electric vehicles. Obviously, when you are able to reduce the weight, you get better distance. So that you can achieve more miles. How to do that? Obviously, the traditional components, like interior plastics, exterior plastics, frame. So these are some of the traditional components. Yeah. So the OEM, from a OEM, they look at it. How do I reduce these traditional components? Do I need such a strong frame? When I move that to electric mobility, means when you have a powertrain, the powertrain engine is very strong. Vibrations are more. You need lots of ruggedness. When you come to EV motor, very calm, quiet. Should I need such a strong frame? Example, then comes to the other plastic items in a vehicle. Should I able to or can I able to reduce, or by changing the different types of composite material, some of the things like cup holders, ashtrays, glove boxes, which are interior and exterior plastics, door frames and so on. So obviously, as Mani said, the visual testing, sometimes simulation, helps for OEM to find out the better material, better design. That helps. The second is also the aerodynamics design. This is also another area. I think maybe Roger can add more value to that. When we design a vehicle, what kind of aerodynamics we can provide, and that can provide a easy riding, and that again can also provide. So these are the two things. Then now comes to the addition and deletions. When you look normal powertrain, 500 plus components, that get reduces to 10 plus components in the EV. So obviously you have a reduction. But then this comes with a headache of battery and battery pack. The huge battery which is going to sit on the vehicle, this is going to add the cost. Yeah. So obviously you cannot do much with the cells and the other packages, but the cover and the case, and how do you integrate that? So that's another area where the weight reduction can be done. Nevertheless, the cooling is another area I want to also say. When you add this kind of power components, which has a lot of thermal related things, cooling becomes another challenge. Most of the ICE, you achieve either air cooling or natural cooling. Whereas in this case, when you have higher power vehicles, you need sometimes a kind of coolant cooling is needed. So that also adds to the weight. So a better cooling method, maybe a better design of the cooling system is maybe important, and better package design, better interiors, and better frame. So those are some of the things which has to be worked out.
Can you define better? How do you see better?
Yeah,
better,
so
on
better
what parameters?
Yeah, so better basically in a material. For example, let me say one example. Yeah, in a particular application, you are using let's say aluminum or a die cast component. Yeah, let's say you use a lock, for example, in a vehicle. Yeah, should I continue to use an aluminum or a die cast part? Can I change that to plastic, for example? So how do I do that? I mean, so you need to meet the strength, So when somebody access the vehicle, he will put a certain force on the vehicle. So the force, the Newton meter strength which is required has to be met. For example, I talk another, for example, wiring harness. If you take the conventional copper wires are there. Yeah, am I able to reduce the thickness of the wires? So obviously 12 volt and 48 volt, 76, 90, 72 and 96. When I increase the voltage of the system, can I reduce the current and then reduce the thickness of the wires and then reduce the weight of the vehicle? So these are some of the things. Similar way, when I come to plastic, different plastic of the so those things can also give a reduction in the weight. So I can discuss a lot, but yeah, there are other experts also available, they can add.
So Roger, I'll turn to you now because you are the user. Suresh mentioned a lot of changes that we can bring about to reduce the weight of the vehicle, and that means clearly you can increase the efficiency by way of that. Do you think that how much of it is doable when it comes to meeting the safety standard and other probably standard that you would like to have for a safe ride of your customers?
Well, I mean, the thread through the conversation that we've had so far has really been around, this difference between historical ICE vehicles and what we see now will be the changes required for electric vehicles, not just in their drivetrain, but in their structure overall, right? So one of the things that you see is that we've been making ICE vehicles for so long, and it really doesn't matter if that's a two-wheeler, a three-wheeler, a sedan, or a truck, that some of those design elements have kind of become design canon for us, right? So we've got 100 years of regulation, 100 years of carrying a heavy iron engine in the front of our vehicles, and that's a whole education system that's been designed around that architecture, right? And I think, if we go back to where analysis, CAE computer analysis, where you'd really use the full Siemens suite, is you really have to throw out now this 50 years worth of baggage that we carry from having produced ICE vehicles for so long, and for having our education system for engineers that are focused in automotive focused on that ICE system for so long, right? Because there are a lot of architectural differences that are possible with a smaller drivetrain that has a lower center of gravity, has lower vibrations, has a much smoother torque range, right? So when you take all of these things together, instead of talking about them incrementally, well, we'll just do some tire work and we'll do a little bit of structural work and we'll replace some things with plastic, right? And then those little things, they will help, right? It's really important though that we think in an open-minded way what all of the items that we're going to carry from the ICE world and the electric world are going to be, right? And we better throw them all away unless they're absolutely critical to some other things as well, right? So if you look at the space frame, the subframe on a four-wheeled vehicle, it's not only designed for safety requirements, but over its iterations over 50 years, it's also become very structurally hollow and reinforced in a way that reduces the vibration throughout the vehicle relative to an ICE engine, right? And those things are not required anymore. But we've been doing that so long as an industry and a transportation infrastructure, right? It's sometimes hard for people to imagine now what's possible by having some of those constraints gone. And sometimes people don't even understand what constraints we were designing to in the first place, right? So again, the important thing is you kind of open your mind. You have an electric vehicle, you have this lower center of gravity, you don't have this large volume of liquid in the back sloshing around, you don't have this large power plant that's only 15% efficient and has a huge amount of torque and off balance vibration in it, right? And you have to take all of those things into account now and say, how does that change the entire vehicle, right? And it's really important that you kind of understand that you can take a blank sheet of paper and just sketch in the safety issues and features that you want first, and all the rest of it's totally open to you, right? And that's really the difference that we're talking about. And that's why analysis is going to play such a huge part going forward, because now we have to lose all of these paradigms that we've carried with us throughout our careers and our educations, and our colleges are still focusing on, right? To understand it's a brand new day, right?
Suresh, I'll come back to you again. You talked about plenty of changes that we can probably bring about in the vehicle to reduce cost or make it more efficient or more friendly with electric vehicles. Can you tell us how much of it we can achieve when it comes to the cost competitiveness? Because Indian market is very sensitive when it comes to pricing of product. Is it only the price point, or is it only the cost that is an hindrance in adopting those kind of changes, or do we not have enough R&D or technical know-how? Why are we not able to achieve that optimal level of changes that you just mentioned?
Yeah, good question. So I can answer in two ways. I mean, knowing India, a country with lots of startups and known for the frugal engineering, definitely possible. But why in EV we are a bit slow? I use the word slow is because of the preference of the OEMs today. Because as I said earlier, the concentration more today in the market is for ICE, because as a tier one company, auto ancillary, when a person puts the money and we want a return on investment on that. So the question always comes to us that is this the right time to invest? So this is one of the things where the OEMs and the component guys are little lagging on the speed. So government is pushing us, of course, through FAME policies and other things. Now comes, are we capable enough to do that? I feel yes, it is definitely. Look at the EV. EV consists of what? Electrical components, you have battery pack and power electronics, yeah, then cooling system. So I'm just talking only the traditional EV component. You have a lot of other add-ons that can be always added. Okay, in these components, what is the backbone of it? Yeah, I'm just right now all the is way in our discussion. I'm concentrating on the core of drivetrain, which is nothing but your motor controller, DC-DC converter, charger, and so on. So the core of that technology is power electronics. Yeah, look at in India in 1990s and until 2000, we were very strong in UPS, SMPS. India was a country, very strong in making the power supplies for the computers and so on. But then over the time, this knowledge vanished because China and Taiwan picked up, especially on the semiconductors. But now it is regaining back. But now when we get the policies and other support, I think this is still possible. So which means a tremendous potential available in terms of talent to regain this. Then supported by the other industries. So I always say that CASE, and we all know CASE, connected, autonomous, shared, and electric mobility is the future. Time being, keep autonomous away, because connected, shared, and electric are, I would say, a knitted component of a vehicle. Autonomous can be achieved even for ICE and also EV. Okay, in this one, the EV always goes with the other two, which is connected mobility, which is telematics, and also the shared mobility. When I mean shared mobility, most of the EV things also need, for example, when you have to give an access to your friend or your family members, should you need to still give a traditional way of giving an access by passing the key, or can I do it in a different way through mobile app and so on? So you basically need a telematics. Telematics, of course, when you have an EV vehicle, important is the state of charge, for example, the last mile connectivity. So that brings the importance of an IoT in a vehicle. So the telematics on board becomes a kind of a nearly a must device in a vehicle, added with the shared mobility, which could be like a keyless entry system. Okay, now are we having the potential on these, or the talent to do that? First is the talent, yes, because our company, that our group, and I mean the automotive group, the ACMA, CII, SIAM, and so on, a lot of initiatives in this space of autonomous connected shared mobility. We have a lot of startups in the connected mobility, in the telematics setting. So things are coming up, shaping up well. It's question of only the time, when we are under pressure, then the things will start coming out. And slowly now it's coming out. The last few years, I would say last 2 years, the tremendous growth happened in the power electronics area. Now, a lot of companies on the DC-DC converter, motor controller, chargers are in India. And, I think Roger would agree to me. An Indian company like us, Spark Minda, we are supplying components to Netherlands. For example, the ETAuto, the company. So like that, there are several other companies. An Indian company started doing it. So this is possible. Yeah. So only thing is the ecosystem should start developing, and then gradually this would move fast.
Let's come back to one of the most important, question of power, which is battery. We do not have a single battery manufacturer. We only make battery packs. We don't manufacture cell at all. So that's over 50% of the cost of the electric vehicle that is completely imported. Apart from that, you talked about we might be good at power electronics, but if you look at the current electric vehicles, how much of the component is really sourced locally? We may be supplying to traditional vehicles, ICE engines, and others everywhere around the world, many parts. But are we really capable of supplying to electric vehicles? How much are we supplying to electric vehicles? If you talk about infotainment system, electronics, high electronic contents are still imported from China. Look at after immediate effect of COVID-19, some Indian OEMs, which has huge dependence on China, had to cut down their production massively. In such a scenario, we see a lot of vehicle designed in China. They're just brought in and assembled, especially in two-wheeler space, and sold in the Indian market. In such a scenario, developing a local supply chain, we are talking about being, Atmanirbhar, or in the current week, we have seen the kind of development that has also forced us to think on being local. So what is the potential? How far are we from becoming local? How can we become self-reliant in electric vehicles system supply? I would like to hear from everyone.
Okay, you take and
Okay,
then.
Amitabh.
Okay. So, I mean, the only reason for taking this first is because we've had, experience doing this for the last 7 years. Our initial goal always was that we will try to be as much independent of, any kind of import as would be possible for the segment that we're targeting, for the area that we're targeting. Whether it is, and I'll be honest about it, whether it's importing magnets or whether it's importing electronics or anything like that. We found that if you do engineer yourself and design yourself well, you can actually create fairly innovative solutions. Today, Altigreen has 24 global patents that have been granted to it on its technology. You can actually do that and still be able to meet price and performance goals that are expected in the segment that you're targeting. So I think it would be absolutely key to develop supply chains within the country, especially those that, for the, once again, for the segment that you're targeting. I think we should be in a very good position to actually create those supply chains within this geography. Number one. Number two, on the battery side, ISRO does have the technology, and if you recollect, they had tried to also attract Indian companies who would come forward, and I think they chose one partner. If I'm not mistaken, it was BHEL. Maybe there are other partners too. So you will very soon start seeing cells being fabricated in India. There are international companies that are also setting up shop within India because. Again, it's a good thing to have that government regulation, also subsidies tied to indigenization and Indian production. All these things are going to be extremely important. Price is a big pressure, because of which we do need to innovate in providing both price and performance together. So I think the steps that we are doing are the right ones in the right direction. I think we just need to focus, and the support for this ecosystem needs to continue. And I think a lot of the panelists have mentioned that what we call as the competency track, or the exploration versus exploitation trap, that a large part of the incumbents typically need to think about or fall into, which is why large investments are not made to newer programs. I think once that mindset change happens, once more and more products start coming out in the market, automatically customer perception changes. Customer perception towards good rugged vehicles that can compete with conventional vehicles. The moment that happens, I won't call it the tipping point, but that is the point where you will suddenly start noticing a lot more happening in the EV ecosystem. And hopefully by then
Suresh,
there'll be a lot more.
Suresh, I'll tweak a bit of the question for you. Apart from battery pack or battery or cell, what are the other components that can 100% be supported by Indian suppliers like yourself? And you would send out a message to your counterpart in the country to up their ante in those direction, because that is easily adaptable, easily you can start production. So can you give us a sense on that?
Yeah, sure. See, we already spoke. I think Amitabh also very clearly said, when it comes to the battery, the cells manufacturing is not exist in India. That is correct. But a lot of new companies, along with Indian partners, they are setting up in various parts of India. So we have already seen 7 to 8 such startups are already happening. Cell manufacturing is a challenge because of the raw material, because the natural sources of raw material. India still have lack on that, and maybe over the time, depending on the availability of the resources, the situation would change. But I'm saying, why should we worry on that? Still, we can do import of the battery and then do the manufacturing in India, either through either a cell manufacturing or a battery pack manufacturing. The reason I say it, So how are we doing in electronics today? The semiconductors are still not done in India. I mean, it's all the wafer factories are still outside, and still we are cost competitive, in electronic space. So similar way, I think a battery pack, though not done now, but it will start with a packing battery pack, assembly together, and then slowly moving into cell, which is possible. Let's talk about your question of the other components. Yeah, what are the other components there in the vehicle? Like I talked in the previous thing, the power electronics components like motor controllers, chargers is another area, DC-DC converters, inverters, vehicle control units. So those are some of the electronics, components, which we call it as power electronics. Motors is another component. Yeah. So now the question is that is India capable of doing that? I would need to answer with a segment, for example. See, let's talk about two-wheel, three-wheel, pass car, commercial vehicles. The majority of the EV penetration will happen in two-wheel and three-wheel, due to which lot of concentration of the tier ones, gone into that space, in terms of research, in terms of design, development of component for that. And we know that two-wheel and three-wheel will have a higher penetration, and it will happen faster also. But if I invest on a passenger car or a commercial vehicle, it would take time, because I don't know that how long it will take for me to get my money back. So lot of money spent and research spent and design spent. So the availability of the component for that exists today. So especially in the segment which I'm talking about, two-wheel and three-wheel. But then when it comes to the high performance segment like passenger car or commercial vehicle, yes, we are still lagging. That would take some more time for us to gain that knowledge. But other part of that EV vehicle is same, because we are all been doing. Tatas are there, Mahindras are there, Bajaj are there. We have been doing it. Plastics we are doing it, die casting we are doing it, and all other things are indigenized. I mean, it's no major change. I mean, every tier ones, every OEMs have a local R&D here. So I do not see any major change there. I think it is quite possible and feasible. So it's question of only time, and it would happen.
Thank you so much. We are running out of time. We'll take questions from the audience after 10 minutes. But before that, I'll just come back to you, Mani. What we are hearing that strong, focus comes on design and development. When we talk about new trend in the electric vehicles, or how do we rethink electric vehicle after COVID, or when we try to make it a self-reliant or locally produced electric vehicle, in such a scenario, where do you see, how do you see technology can play a role, and how technology at a cost which could be achieved by a large number of manufacturers, be it a startup or the already big players? I hear that from a lot of component manufacturer that the affordability of the technology is very high when it comes to manufacturers in India. Do you have any comment on this?
Sure. Thank you, Nabil. So the first comment I would like to make is there was a lot of talk. Suresh brought it up, Amitabh brought it up with regards to the cost involved in a lot of the components. So one of the areas where we can really help, where technology can really help, is let's say we have multiple parameters controlling a particular requirement. It could be weight. We are trying to minimize the weight. Now, if we know upfront what are all the components which can be varied in terms of design, and then from a structural point of view, if we know what are the constraints that need to be satisfied, then we have technology which can run multiple scenarios. So you can think about it. If there are 5 or 10 variants with 3 or 4 constraints, then there are numerous scenarios which actually need to be analyzed and worked on. So this is an area where I believe we have made a lot of progress in terms of technology. I can give one example. There was a military vehicle developer in the US, I believe, and they had a very complex military vehicle with so many components. So we had about 20 different parameters that could be varied, and there were 5 or 6 constraints that had to be met. And essentially, we use this technology to study all the scenarios and came up with a solution for the customer which had a significant reduction in the weight. Now this technology is neutral. It can be used definitely in India. And when we face problems along those lines, I think this is definitely going to help. So that is one example I can think of. Similarly, if we look at design of batteries, we're always focused on increasing the energy density of the battery. So there could be 5 or 6 parameters associated with your cathode, anode, and the electrolyte that is in between. And if we have a design tool, we have a battery design tool which can help design batteries, and then we take this design exploration tool and tell, hey, these are the constraints. With these constraints, can you go ahead and maximize my energy density? We're able to come up with a solution. So I really think that technology can play a very, very important role in helping us bring down the cost. And one final point I would like to make is I think one of the challenges we need to keep in mind is that we always don't have to solve the ultimate problem. Any problem can be broken into smaller pieces, and sometimes I think quest for the brilliance, we tend to forget what the big picture is. It's fine if we break the problem down into smaller pieces and we solve those problems. We can get there, I think. So a little bit of mindset change, I think, along that area would definitely help. So those are a few points from my side.
Thank you, Mani. I'll come to you, Roger. We are talking about high density energy chemistry for batteries. And in a market like India, thermal efficiency, because we have varied, temperature, we have up to 2 degrees Celsius, even in minus some region, and you have going up to 45, 46 degrees Celsius, sometimes 48 degrees Celsius. In such a scenario, how do you deal with these challenges? Two, one is of high density energy chemistry, what is apt for India. Second, how do you deal with thermal efficiency?
Well, I think, so the extremes we see here are all on the high side in India, right? So up to 50 degrees is fairly normal. And a lot of the chemistries that have been developed specifically for automotive, and we're talking mostly NCA and MC here, have already taken those into account due to global standards for temperature testing for automotive. So you don't, as we've classified cells at Ola Electric, and we've taken cells from all over the world, basically. So we haven't seen a lot of cells fall out of our consideration due to temperature issues. It's always been much more on, we feel that there's the need in India to have the shortest possible charge time, for example, right? So a lot of people that are using electric vehicles today are using them for commercial purposes, and downtime is a huge consideration for the electrical vehicle industry in India right now, because again, it's going to skew commercial first. But as far as the temperature issue goes, as long as you stay out of the higher new chemistries, so the 8500s, that type of thing. But the middle of the road chemistries that are already in electric vehicles elsewhere have really already been tested to those temperatures that we see here. And I think the only real unique thing that I've seen in the market here is there's a lot less tendency to have a high-powered cooling system, right? So you have either no cooling or light cooling, right? And then you start now to have to do some balancing in your chemistry to take care of your life cycle management, right? So the cell suppliers that we've been dealing with so far, testing specifically in conditions, all of those discussions have been around how do we specify that chemistry, those test specifications to take into account those special circumstances that we see here. So where we have these high temperatures, and we prefer not to have high volume circuit cooling because of the cost implications. So I don't think you need a special chemistry for India. I think the chemistries that are on the shelf are 80% of the way there, and just some real small tunings, especially in the anodes, can take care of most of those issues.
I would additionally add
Anybody
also
wants to? Yeah.
battery management systems. Yeah, no, that also plays another big role. I mean, the core of the battery management, and adapting the curve, the charging curve, discharging curve, and so in the hardware or software or BMS is also another point, which is possibly needs to be tuned, calibrated for India, Roger.
Oh yeah, just real quick. So there's a definite difference in the algorithms that we have for India-specific BMSs as opposed to outside the country. So in that case, you're absolutely right. So we haven't taken any off-the-shelf algorithm for Ola Electrics products. Right? We've developed those all in-house, and they're very, very specific to these conditions. So that's a very good point.
So before I go to the questions from the audience, I'll come back to you, Pradeep. Thank you so much for waiting patiently. So I just want to understand that how important is TAR again? Can you give us a factual understanding to the people? Why are they still ignoring this particular component, which you just claimed that it is one of the most important, which I also feel, that's why I have called you in this panel, which was always ignored. So can you share with factual examples how much of efficiency, how much of comfort, or overall performance of the vehicle can change if we have right tires for electric vehicle? I do not think there are tires being made available specific to electric vehicles.
Yeah, I will use this opportunity to give a fair reply for this. Let me start with the gasoline powered vehicle. Gasoline has more energy than battery power, almost 50 times more energy density for the given weight. So what happened in the case of electric vehicle? My job will be to extract maximum miles per every watt, which is the contribution from the tires. And the tire needs energy for rolling. There is an echo. A tire needs energy for rolling, and in the case of EV, it can be as high as 20% of the total energy available in the EVs, the battery pack. So my priority will be to reduce the rolling resistance. Roger also mentioned a little bit early. Rolling resistance of the tires. Reducing rolling resistance of the tires is of our prime target. And I will also mention about other requirements which are basically conflicting in nature. The low rolling resistance for a maximum range for the given charging. And at the same time, the EVs have very high starting torque and a continuous torque rating. The tire needs to develop sufficient traction potential. It has to have proper grip using its frictional potential, reduce its slip. So the tire needs to provide maximum traction. And when you say traction, it's a work done by the tire. And whereas for the lower rolling resistance, you need to have less work done by the tire. It's a conflicting requirement. And also, when you say gasoline has more energy to match with the equivalent performance of an IC EV, you need to have a very heavy battery pack, which everyone knows. So ultimately, the tires have to carry this load also. So the heavy load carrying is another requirement. And when we say the tire has to provide maximum traction, it has to abrade less also. Otherwise, the total tread mileage of the tire will be very less. So again, it's a conflicting requirement. So high traction with less abrasion, and we were all talking about lightweighting. Lightweighting will apply for the tires also. Tires are basically the unsprung mass. So lightweighting brings down the inertial loads. So that is also a priority for us. But when you do this, the transmissibility of the system changes. So the in-cabin noise, what will be the effect of in-cabin noise? That also has to be studied. So there are a whole lot of requirement changes in the case of EVs, and tire has a definite role to support in all these aspects.
Okay, before I go to take the questions from the audience, if you have any question from your co-panelists, you are free to ask.
Maybe I can ask Roger, not a technical question. What made Ola to acquire ETAuto?
So, sorry, repeat the question. I missed the middle of it. Why did we acquire ETAuto?
Yes. What is that you see the value proposition? Maybe possibly you would have thought a value proposition. Yeah.
So Ola Electric's goal is to be in a global electric mobility company, right? And not just in the ride sharing space, not just a ride aggregator or any kind of taxi company, but to be very, very much involved in spreading the use of electric vehicles from last mile usage all the way to four-wheelers and mass transportation as well. So it's very much, Ola is very much a personal customer-based company, so that they, it's very much a people company. So all the conversations you hear in an Ola office are all about customer and people and how what they can do to help them. They're very much about helping people, and it's very important to Ola and Ola Electric in particular that the environmental benefit is there. So there's actually quite a large economic benefit to people that make use of electrical transportation as the battery cost comes down. And then overall, the longevity of an electric vehicle and the recyclability is much better than an ICE vehicle, right? So all of these factors through the strategy where we were strictly, intensely focused on being the best electric mobility company we can be. And that includes two-wheelers, three-wheelers, four-wheelers, whatever that takes. And what we saw in ETAgo was just a product that was so much better than its ICE counterparts and its electric counterparts that we felt that would be a great place for us to start on the retail side of this, right? It's easy to sell somebody something that's great, right? And in this case, we're looking for great electric vehicles. And it is, so I think we're going to have great success with that product and that platform.
So they want to complete this circle. That's, yeah.
I have a question for Roger. Roger, we have been talking about shared mobility. In the given situation of a pandemic situation, there is a fear psychosis in traveling along with others. So what will happen in the future?
We can already see it. So you'll see people, and it depends which market we're talking about, right? So Ola is a global company, so we see very different habits and new behaviors in Australia and New Zealand as opposed to the UK, as opposed to India, right? So I think what you'll see if we stick to India is that there'll be a lot more focus on using the current form factors that give you a little bit of separation, and you're less likely to be in danger of becoming infected with COVID, right? So you see a lot more people switching to single or dual person usage of auto rickshaws, for example, right? Or you see a lot of more single person rides in closed four-wheelers, right? And you see a lot more interest in the market in people maybe that hadn't considered a two-wheeler for going back and forth to work before are now considering it. Right? So you'll see the market slightly move towards those form factors and those methods of mobility that offer them some distance as far as social distancing is concerned, right? And we feel again that going into this two-wheelers first, based on the situation, then is a very good thing for the market here, a very good thing for people and people that need to commute and not be worried about getting too close to others until we get clear of this COVID situation. Right?
Thank you. I understand there are no more questions for the co-panelists. Then I can move to the audience questions. Okay. So the first question comes for money. Building digital twin in simulation is challenge. How real environmental condition can be considered in simulation? This is a question that has come from.
I'm sorry, Nabil, I didn't hear the second part of the question. Could you repeat that,
How
please?
real environment condition can be considered in simulation for twins, for digital twin in simulation? I repeat the question. Building digital twin in simulation is a challenge. How real environment condition can be considered in simulation? I think it's a very generic question. Yeah.
Sure. So I can probably answer that question with one example. So at the outset, I would say that mimicking real conditions are challenging. But we have been doing for instance, if you look at ride handling studies, we've been doing a lot of that. So first, we typically start with a controlled environment. So it could be just a vehicle driving through, and then you have a wind coming at 90 degrees, which is maybe easy to simulate. And then perhaps the next step is to take it to multiple directions, which makes it a little more challenging. And then completely making it random is definitely a little more challenging. But the fact that we're able to do the basics, I think it's just adding another level of complexity on top of that. And the other good thing I would say is that it is not that everything needs to be done by a single tool for a particular application. So for instance, even for this crosswind case that I'm talking about, what we did is we coupled two codes. One is a CFD code from Siemens, and the other was MATLAB. So MATLAB was the one which was actually giving the various positions of the vehicle, the response of the suspension to the aerodynamic forces that are acting on it, and then by communicating between these two, between these two tools, we could do a fairly realistic simulation of a vehicle driving through a crosswind. So I think it is a challenging problem, but we just have to look around for what is available currently and then find the right mix, connect the products together, and then help us mimic the real world environment.
So next question comes from Rupak Sharma. He wants to ask, the biggest cost is battery. Is there a sustainable model where the battery is treated at par with fuel? How can we have a subscription model or something like that, where one can bring down the initial acquisition cost and of an electric vehicle? Is there a possible model, subscription model, cost competitive subscription model? Because currently the subscription models are very high cost. Roger and Suresh, if you could add.
Yes, so there's we have an answer at Ola Electric for that. So we've gone through 3 years now of analysis in real world conditions with battery swapping models of different types, different chemistries, different ways of paying for it, different ways of procuring the electricity for that swapping model. So in India particularly, where we have very competitive energy costs, it's possible to have a swapping model that takes into account the cost of the battery cells and the cost of electricity to charge those batteries when you swap them, and still be far below the cost it would cost you to fuel a two-wheeler, three-wheeler, four-wheeler at the current fuel costs that we have in the Indian market, right? So there is a way to do this, all right? And it's very much based on making sure that you have a robust battery that lasts for a certain amount of time and has a certain capacity and so has a certain ease of use and availability. You put all of those things together, it actually makes a better use case and a more convenient way to fuel your vehicle than even gasoline does. So yes, there is an answer for that, and you'll see it very soon. So pretty soon we'll be full on with the launch of our batteries and system service, and it does solve those problems, and it is proven. Right?
Additionally, I can add to Roger. I think we know also the upcoming try in India, and especially also by the government, is the swapping technology, the battery swapping technology being also tried out. And especially in the three-wheelers in northern region, I think this has been tried out. And I heard also it's pretty good, which nothing but moving from a capex to an opex model. Instead of charging the buyer heavily on the capex, but more into a kind of an OPEX model based on the usage. I think this is also a successful model in like a company called Gogoro, you may know, in Taiwan. So this is the one area where the battery costs can be brought down. That one. Second, if it is still a battery goes with the vehicle, after some time in a year when we accumulate certain cells in India, then recycling can be a one area where the cost can come down. I mean, passing the to the chemical process, mechanical process of removing the components and then taking out the cobalt and nickel out from these are the two expensive material of the battery. So that costs about 40 to 50% of the cell cost. So taking that out and then reusing that is another area where the cost can come down. So I think yes, these two can also add some value.
What is the longevity of a lithium-ion battery, if you could give us a sense? Because I'm a user, suppose I have to replace a battery after 2-3 years, then what is the point? Because that's the 50-60% of the cost.
So very difficult to answer, Nabil. 3 years, 3 years. But I can say that compared to the lead acid battery, the conventional one, you all know that it's lead acid. Lithium-ion have a better reliability, better longevity in terms of life. It also depends on the usage pattern, so very difficult to say it's 2 years or 3 years. But definitely, I can say kind of an Indian use condition, 3 to 4 years should be possible, and maybe also beyond. That also depends on, Roger was saying earlier, the chemistry you choose for the country, it also depends on that. So what kind of a chemistry, the cycle India is temperature, humid conditions, and in that conditions, what kind of a chemistry you choose and what kind of an algorithm you have it in the BMS and the cooling systems. So that also, helps you to achieve more life.
Yeah, Amitabh, want to add quickly?
Yeah,
very precise.
Yeah, I was just trying to add that, very soon models are going to develop, and it's already happening, where people are going to get access to batteries either on a leased way or on a per usage basis, even though they might be using fixed batteries. And hence this whole problem of, very expensive batteries and how long will they last and all that is going to get out, because these leasing companies have their own ways in which they can use these batteries in second life and third life. So you'll see those things evolving. The customer will not have to deal with this problem. You will start noticing that change happen very soon.
So next question comes from Babita Bhan. Our new seat back panel product replaces stamped steel panels, delivering the automotive industries. Okay, they have developed something, and they're just giving an example where they have been able to bring down the weight. So I'll skip that, and I'll take another question from Sanjeev Das. We are all talking about battery, powertrain, and whole vehicle at large, but what about infrastructure on the charging, battery replacement? What do the panel feel on this? I think we already have a recycling plant available in India, but anybody wants to add something on this?
Energy production in India currently, about in the last, well, it's a little bit different now with COVID, but so let's say in January we were around 73% petroleum based, coal based, burning based, right? Pollutant based, and about 27% of some kind of renewable energy, right? So if you look at the infrastructure that's under development now in India, within 5 years, that's going to come down to about 52 or 3% already, right? So as long as that trend continues, the environmental impact of electric will continue to improve, and you'll continue to see your air quality get better, right? You'll continue to see less carbon issues in the atmosphere. The battery cells that everybody is using now are pretty highly recyclable, so you won't see a lot of environmental impact from having to throw cells away. So I think if we look at the the current condition in India and where we're going and the money that's already being spent on infrastructure, it's a pretty positive message. I think the Indian government's done a great job of bringing those things about in a very fast way. So,
I would like to add one point. BEVs are still more efficient, even if the energy is coming from polluting energy generation. And also there is no tailpipe emissions. So anyway, it's a better situation.
Okay. I'll take one last question because we are running out of time before we get into the presentation. Saurabh Das, he asks, we import a large amount of raw material, be it lithium, cobalt, or we have a bit of graphite here, manganese, and largely these are imported raw materials. That increases the cost. What the Indian ecosystem of the EV or automobile industry or the energy industry is doing to reduce the cost, which is largely due to import? Are we going to get into some kind of trade agreement with the country which has ample of lithium like Brazil or Chile or other countries?
I think it's happening on as we speak. I think you just search for it. There are investments that India is also making in South American, in lithium mines in South America, in Australia, and other places. So I think it's a clear understanding that this is an area that we need to address. Battery technologies are also changing very rapidly. Sodium air, aluminum air, graphite, graphene, for all nuclear fission and fusion also in the near future. So I think there is an investment that's continuously going on in that area. People are aware of it, how much, and whether it's appropriate. I think that will determine the scale of adoption of electric vehicles, largely because of price and performance.
One last question, because there's so many questions, I don't feel good to miss all of them. To you, Amitabh, if you could answer quickly and in short form, what impact COVID is going to have on last mile connectivity, especially in terms of electric vehicles?
Yeah, and we were just talking about it before the session started. I think for EVs in last mile transportation, COVID has been like the silver lining around the dark cloud. I think shopping as a social experience is going to deteriorate over the next 18 months to 2 years, and hence e-commerce is going to increase really rapidly. And the moment you have more e-commerce, then you need more vehicles for delivery, whether it's two-wheelers, three-wheelers, or small commercial four-wheelers. So last mile transportation, definitely. Sharing is another thing that's going to come down, which means that more vehicles will need to be adopted by people who are maybe a little paranoid, but maybe rightfully so. You don't have enough buses, public transportation to take them, so you will need to own more vehicles, and that is going to happen in LMT. So we're very positive about it. We're already seeing that happen.
Thank you so much, everyone, for joining ETAuto, and I'm so sorry for the delay due to some technical glitch. To get more detail on electric vehicle, on July 23rd, ETAuto is organizing a day-long virtual symposium and conference where over 25 global experts in the electric vehicle space is going to be there. They are going to give presentation. Do join us. Visit ETAuto.com to get more detail on this. And thank you so much, everyone, for your questions. And thank you, ladies and gentlemen, for listening to us. And thank you, Amitabh, Suresh, Mani, and Roger, and Pradeep for joining. And Pradeep especially for giving us a new angle, how tire can be important component for electric vehicle. Thank you so much once again. On the other side of this panel discussion, we bring to you a detailed presentation by Rakesh Pandey from Siemens on this subject. Stay tuned. Thank you so much once again.
So, in the next 30 minutes, what I'm going to do is, I'll just walk you through a couple of challenges, which most of the panelists were talking about. And then also, I'll just show you, what are the solutions which they can look across, and especially from Siemens, what we offer, Amitabh was mentioning, right? So EV was present much longer, So can you guys make a wild guess, how long? So you'll be surprised to know way back in 1828 to 1835, they were small scale electric cars. So it's close to 200 years, 2 centuries, almost 2 centuries back when the electric cars, came into this world. But this is a small summary, which I got it from Sharp magazine. So they started with that, but 1920 was an era or the decade, wherein they were overtaken by much efficient, much what you can call across much more variants, of IC engine cars. And who did it and which company killed it? Let's not go into that. But then again, way back in 2011 onwards, then again it started up, especially with Nissan coming with their Leaf model. And of course, 2012, Tesla launched the Model S, although they had come with an earlier model called Roadster, but nobody noticed it. But Tesla started that initiative just 8 years back with their Model S, and then it slowly started picking up, again. And the future is again bright for electric vehicles because of this COVID. People are realizing when the IC engines are off the vehicle, off the road, there is the climate. There has been an impact on the climate. And I'm not saying about the WhatsApp Unicity, but also people are feeling it about it. So that's about the electric cars. Can you make a guess about your electric scooters and bike? So they are not that old, but still they are more than 100 years old. So the first patent of an electric scooter or a bike was done in 1895. That's the earliest patent, which people have, or which was registered, and after that there have been some movements, although it was slow. But 1936 was one of the main milestone, wherein especially an electric motorcycle company was formed. 1967, Union Carbide, came with a nickel cadmium battery, for their electric vehicle, which was a hybrid vehicle, which claimed to give 320 kilometers and with a top speed of 40 kilometers per hour. And I'll not go into the details of others, but 1996, Peugeot, the French company, they launched their first mass production of electric scooters. And then, of course, in 2011, just this last decade, or rather, I'll call the start of this decade, Chip Yates, he set a record of 316 kilometers per hour speed for electric bike. So you can see, there was a lot of mileage, there was a lot of speed, in this electric motors. They also started launching electric motor racing, and then I think Mr. Suresh mentioned, right? So this Taiwanese company, Gogoro, they rolled out their very smart scooter, and it was owned by not the traditional automotive companies, but it was owned by HTC, the mobile company. And 2017 in US, there was a battery which was launched for this scooter, and this scooter was known as Espresso, and this battery was lithium titanium oxide, with which they did a proto, and they could claim that this whole battery can be charged in just 10 minutes, and it can withstand 25,000 charges. That means close to 60-70 years. So the battery might outlive your vehicle itself. And although if you see the Tesla's lithium-ion batteries, wanes out in 6 to 10 years. So that's a major improvement, and that some countries have started building on top of this particular battery technology. 2019, okay, there was a more electric motor World Cup, and 2021, I feel that there is a big opportunity for electric two-wheelers, three-wheelers, and of course four-wheelers, going forward. So this was a basic timeline just to highlight to all our audience that this particular technology has been there. What is required is more adaptability of this particular technology when they come on the road. Okay. Now, with regards to Siemens, again, we are 170 years young company, and not with the start, but now in 1879 we started by delivering the first electric locomotive engine, to Berlin, and that's how our history started. I'll not go into those, but in the last decade, what has happened is, like in 2010, we worked very closely with Vienna, the capital of Austria. So all the buses are electric buses, wherein the powertrain is from Siemens. 2011, we started working with the Value, and for all the Volvo cars, the electric powertrain is not only designed, but also the electric powertrains are from our Siemens Mobility, the another unit of Siemens. And these cars are used again by Siemens employees as a shared mobility, So it's not only that we are just contributing in the way of helping any company design, but also we have our own solutions, and we also use those solutions which has come on the road. And 2017, we did a tie-up with Scania. So between Austria and Germany, we have laid down a line, and this whole vehicle, commercial vehicle, is inspired by tram, or you can call as electric train. So wherein the truck can move across, and whenever they want, they can just put up their rails up and get it charged while already riding on the road. So that has a tremendous potential, again, to put across in India for the long distance or the intercity, between transport. So this is again an history, but what are the disruptions? Now, saying that, the question is that, do you think that electric vehicles will pick up, and how soon it can pick up? So people are apprehensive, but I just wanted to show you a single picture of one of what you can call one of the roads called East Parade on the 5th Avenue of New York City. This is one picture which was taken on 1900, and if you can see, there are a lot of horse carriages. This is one single car which you cannot spot somewhere here, but just within 13 years, there was another picture which talked about how the entire horse carriages were replaced by your IC engine vehicles on the road. So 13 years, everything got changed, and there was just one horse carriage, because they were making so much pollution. So things can happen, and things can happen very suddenly too. Now let's see, how it is happening in case of electric vehicles. So if you see this particular chart, and this is again from Bloomberg, if you see this, the first million electric vehicles, it took close to 15 years to get it sold. Whereas if you see the fifth million vehicle, that was sold in just 1 year. So 1 million just sold in 1 year, whereas the first 1 million was sold, took close to 15 years to do that. Now, what is the prediction, going forward? So going forward, the prediction is that by 2040, near about 45%, near about 45% of the vehicles will be the electric vehicles, which will be battery powered or plug-in hybrid, and a small contribution will be there from other alternative fuels. And electric vehicles especially will start picking up, from 2021, 22 onwards. Whereas the real decline in ICE engines will start, from 2030 or in that time frame. But the question is, which segment, of automotive will lead this? So there is again a report on that. So if you see that, especially the municipal buses, the corporation buses, they have been taking lead, and they will increase their lead by 2030 from 33% to 58%, and that is happening in India. If you see in Delhi, the buses are run from JBM, and other places they are getting orders. So this corporations, will be one of the leaders. Electric two-wheelers are already there, but they will increase their market share again, or they will their sales will increase by 10%. Whereas the light commercial vehicle, which is generally used for the intra-city, is one thing, which will pick up quite fast, from 2 to 28%. Whereas passenger segment will also see an increment. It might be a bit slower than what you can see for the municipal buses or for the light LCVs, but they will also start picking up, with all of us being more conscious about the environment. And somebody said, I just wanted to quote that, somebody said, why all this environment, saving of environment, fails, because we say save environment. You don't have to say that. You have to say save yourself. Environment will take care of itself. So that's the crux, which we need to put in everybody's mind, to start adopting this green technology. So this was some of the challenges, and let's see, some of the challenges which have been also discussed by the panelists. And so if you see, the biggest challenge is about range anxiety, right? So it is miles per charge, and what will be the charging time? An average time when you go and fuel up your gas, it takes like 10 to 15 minutes, but will that be time sufficient to charge electric vehicles? That's one question, which is a concern for a user like us, and then the charging availability, But my question again is that you have to go to a petrol pump, right? But the charging station can be put there at a petrol pump, can be put in a mall, like in Bangalore, in Forum we have it. Like ladies, they love gold jewelry, right? If you go to Tanish, they have put a charging station. If you have a Tata or any other vehicle, you can very well charge there while you do your shopping. although you should spend less time there, but so this can be available. It can be available in your workplace also, so the charging infrastructure can be done. And just one more point on that is that we were there in one of the OEMs, and they launched a car with 350 kilometers per charge. So that means an average Indian drives for 50 kilometers, 7 days, 350 kilometers. That means you have to charge your vehicle just once in a week. So I think that's a good value proposition. And of course, like Suresh and Amitabh also mentioned about government regulations. Indian government has put FAME 2, which talks a lot about the subsidies and how the phase out will happen. The third important aspect is the safety and reliability. Now, and this is both, in the urban and the rural, and I'm talking in context of India, wherein if you talk of the urban India, they think that if the car crashes, it will catch immediately fire, the battery will explode, so it's a very dangerous proposition. Whereas if you go to rural India, they think that you can't drive an electric scooter or a bike in rainy seasons, or in water, you can get some electrical shock, So those type of things has to be addressed. That security has to be built into the mind of passengers or the consumers. And then if you talk, so this was from the consumer perspective, from the other side of the table. But let's see from what are the challenges, from an OEM perspective, from a tier 1 or the main system supplier perspective. So one is the vehicle package design, as somebody mentioned right in the panel again. It is easy because you can, it's very less number of components. Like Tesla, they have more, or they have less than 30 moving components. You can do that. But what Roger also mentioned is very important here, is that we don't have to come and develop an electric vehicle with a traditional mindset, which has been taught in our engineering for 4 years. We have to come with a different mindset to build it across this particular new platform for developing an electric vehicle. Of course, we can still follow the system engineering process, the in-cost standards, IC 15288 and all, but we need to think in a different way, while we design this existing platform. Plus, we also need to think about how can we morph the existing vehicle platform, and not only that, what will happen to all the IC engines which is working or which is running on your road? How can you convert that, into that? So that can be another business model, which might be a bit dangerous for the new startups. But what happens to them? Will they still be continued on the road to put the pollution? So let's think about that also. And then again, from the OEM and other perspective, of course, thermal management of the battery, thermal management of the whole vehicle, the NVH, and I'll show you across why NVH is also important, noise, vibration, and harness in case of electric vehicle, and it becomes more important and why it is. And of course, the energy management inside the vehicle. And the last is the market leadership. It's a do or die challenge. So the competition for anybody is not from the traditional players like Mahindra or the Tata Motors or the Ashok Leyland and Aishas of the world. There are companies like Altigreen, we had Amitabh on the panel, we have Ola, we have ETAuto, we have Torque, and many more companies, which are coming with those innovative ideas, plus also the technology companies. We saw HTC's example, but Google and Apple's are also working, of the world are also working on this electric vehicle. So you never know who's your competitor and what they are bringing on the board. So the challenge is big for the electric vehicle companies, or the OEMs, and also the tier 1s. While discussing on this, now what are other challenges, which is there is, one is there's no convergence on the battery yet, on the cell manufacturing, on the battery density as such. So there's much more architecture which is possible. In case of IC, we have standard. If you go for a 4-wheeler, 1 liter, 1.2 liter, 1.5 or 2 liter. But in this case, there's more architecture possible to achieve, a more optimal solution and at an affordable price for the end consumer. One of the panelists talked about, and also we have Pradeep who talked about the vehicle weight reduction. So we were working very closely with Leaf, and they were trying to reduce their vehicle weight to increase the mileage, which they achieved it across from 117 miles per charge to 172. But at the end of the day, the weight increases slightly more because of the battery, But again, the point here is that weight reduction is a very important point, to arrive at a range, which your end user or which the driver will desire for. So this was some of the challenges. I just wanted to show you one more slide. So I was going through one of the courses of TU Delft University, and we have an Indian professor by name, an Indian origin professor rather, I'll say, Dr. Gautam Ramchandra Moli. He is an assistant professor there at TU Delft University. Now, what he talks about, and his thesis and his thesis paper is available on his LinkedIn profile, or you can just, it is there on the public domain, so I can share it across from the link below. But what he talks about is that, and I think Mr. Pradeep from Apollo also mentioned, even if you charge your electric vehicles from coal, still it is less polluting, yes. But this paper talks about, and I would request all the participants, also if you are an electrical engineer or have an interest in this area, go through this paper because it talks about how you can use your solar energy on your house to power your vehicle, how from grid to vehicle, what should be your algorithm, and also how you can give back from vehicle to the grid. Maybe not that much possible for us, but how you can also give from your solar, which you have produced extra, back to the grid. So very nice concept and good algorithms and good system designing. So go through it, go through that paper, if you want to have more interest on making your greener technology more green. So let's talk about, so those was about challenges, disruptions, what people are doing all across the world, about the existence of these electric vehicles. Now I'll just move a bit specific to the different areas, the 6 or 7 areas of an electric vehicle, the 6 or 7 systems of an electric vehicles, and what are the challenges with regards to that, whether if you are a tier 1 supplier of that particular system or you're an OEM, and what are the solutions, and as Dr. Mani mentioned, simulation is also one of the best solutions, wherein you can do a lot of things virtually. Because if you make anything proto, if you make a physical proto, you are investing your time, money, and cost. How you can reduce that. I'm not saying it can be completely reduced, but how you can reduce that so that a less cost and the time is spent that, and you can have n number of variation, design exploration, which you can do through those tools. So let's see about Siemens. So as Siemens and Dr. Mani and me, we are part of the Siemens digital industry. So from there, we provide all the software solutions, whether it is a battery designer simulation or your motor designing simulations. If you want to do your entire attribute optimization of various attributes of your electric vehicle, very well, we can support you. And now if you see, and recently with SpaceX, a program was launched, and if you see the dashboard, it's all electronic. But if you see the previous Apollo launches, you can see a lot of electrical stuff and electronic stuff. So there are a lot of software, also embedded software, which goes into your vehicle, whether electric or whether now IC vehicles. So how can you ensure that the correct binary has gone into your correct variant of the car or the vehicle? That also can be managed through a solution called application lifecycle management, and the tool of the solution is known as Polarian, which is used by Mahindra Electric of the world or the Teslas of the world, and of course on the vehicle engineering. And regarding manufacturing, again, we have a lot of solutions which can help you there, and we'll talk about that. And from the Siemens mobility perspective, we do have, we are not, we are more prominently with these solutions in the European and the North America market, but we have our own electric motors. We have our own charging stations, right from 28 kilowatts to the high-speed commercial vehicle charging stations of 350 kilowatts. And then, of course, the last point is again from them, but from our Siemens Mobility. But this is very important, and especially in case of Ola and other companies in the JBM of the world, which are coming across, that how are you going to monitor the real-time monitoring? If you're into shared mobility, the eDrive health monitoring, you have to do it online. How can you do the energy management of the platforms, the signaling, all the meeting, all the status, and also how much power you are taking from the grid, for charging of your vehicles, which is running on the road. So that's another smart services, which will be another ecosystem, which will also quite fast developed in India, and we can serve across to the world. So let's go into this 7 specific areas, which I will talk about. I don't want to say if you have any questions till now, please feel free to post it on your chat box, and I think Nabil can help us consolidate that, and maybe we can answer that at the end of the session, or I can answer that individually after getting it from Nabil. So let's go into each of the specific areas. The first area is the battery design and manufacturing, and therein we'll talk about the chemistry. Many of the companies are not working on the chemistry; they are not from the battery domain, but they will just buy the package and they will put it across, into the vehicle. And then we'll also touch upon the charging station. So for each of this area, I'll just talk about the challenges because it's a brief presentation. And as Nabil was mentioning, so on 23rd we'll have a multiple sessions, and which will cover all this aspects into more detail as such. So for each of them, I will be just touching on the challenges, the solutions which you can adopt to, and then of course 1 or 2 use cases, or success stories about that. So let's start about the battery design and manufacturing. So the challenging is, of course, people mentioned about the sizing of that, the battery sizing, the battery density, and how are you going to integrate that with the powertrain or the electric powertrain. And that is what a challenge, which will be faced by both the battery manufacturer as well as the electric powertrain or the OEM as such. And then how you can evaluate and optimize those cell chemistry at the cell chemistry level so that you have the maximum energy density so that your mileage can increase dramatically. And now another aspect in case of battery is very important is the thermal management, which also Dr. Mani was mentioning, how you can ensure the proper cooling of the cells happens, because if one of the cells gets damaged, it will have a damaging effect on the other cells, and the whole battery pack as such. And then the last part is, of course, on the fast charging, right? Everyone wants 15 or 20 minutes, and then the vehicle should be charged, but what will be also impact on the battery aging? Because remember, and one of the panelists also mentioned, like India has a very long range, right? Nabil was saying that from -3, we go to 48 degrees centigrade also, right? But for battery, to work in a most optimized condition, the temperature might be somewhere near about 15 to 22, 23 degrees centigrade. So how you can ensure that your battery temperature is maintained in that range so that it doesn't affect your mileage, it doesn't affect your the aging also of the battery. So the solution, of course, is that you need to do a simulation upfront. We have a library of in case of lithium-ion. So you need to do a lot of simulation at the battery cell chemistry level. You can do at the packaging and the design level. Of course, you can do the complete thermal management, and you can explore what will be the most best strategy for your thermal management and the thermal cooling of the battery. And of course, we have solution which is known as Battery Management Studio. So you can do the entire simulation virtually of the battery before even starting the first physical stuff. So all those evaluation can be done much earlier and much before even going starting for the manufacturing. So this is one slide wherein what should be the framework of this particular battery model. So you can complete your microstructure. You can do your complete electrochemistry simulation. You can, if you want to check at the cell level rather than at the microchemistry level, you can do also the cell design and the cell performance. So if you are a company who are just aggregating and making a package, you can very well do that, and therein you can see what will be a cooling strategy. If you are just putting the package together, you can use 1D simulation to also check across your battery with other systems, with the electric powertrain and other, also with your tire and other stuff, to see across what should be your or how your cooling strategy is going to work in the physical world. You can do that also in your virtual world. And with battery management system, you can do all your hardware in loop, your software in loop. So you can do very well that also, before going for your real production upfront, virtually, everything in the virtual environment for the battery. Now, this is one of the case study. This is for Samsung, which we did it for their India unit, wherein we helped them to improve their cooling system for their cylindrical batteries. And it was very much important, for the high performance and the longer life of the battery. And simulation helped them, to narrow down, how they can narrow down the temperature range, which will be very optimal for the performance of the each of these cells. So similarly, if you talk about the charging station, now charging station also, once you do the fast charging, now for that also the battery needs to stay below the maximum value to ensure that the calendar life of the battery is again more. And plus, what you need to do here in the case of charging station is ensure that there is less of lithium deposit, So if you can just simulate that virtually and ensure that how the capacity of that can be increased of the charging station. So very well you can do those simulation also. Now another aspect in this case is, apart from the battery and your charging station, is the mating point, right? So now the mating point, the temperature, the max temperature, if it goes like 77 degrees centigrade, there's a possible chances of the skin getting burned out. So how you can ensure that the liquid cooling can happen at the mating point, so the temperature remains at an adequate level of like 27 degrees centigrade, so that you can do those analysis also upfront. Okay. So now that was about from the design and simulation perspective. Now, when you go and do the manufacturing part, you need to ensure that your calendaring, your mixing, your drying, your sitting and punching, while you are making that particular battery pack, your electrolyte filling, your formation, your grading, all that happens in a proper way, and you can control that at each stages of your battery manufacturing life cycle. So that can be done through our solution for battery manufacturing, right from your design, your planning, how you are going to do that on your shop floor for the battery, your production engineering and execution, how you are doing right at that moment for at wherever stage the battery is, whether it is in the punching or it is in the assembly stage or the electrode filling stage. And then of course, once the battery is out, you can still go ahead and track it, how the battery is really performing as done in the virtual environment, in the physical environment also. Okay, so that comes to for the battery design and manufacturing. So I'll spend under 5 minutes on the software controls. So as I was talking about, there is an exponential growth in the software complexity. So I just recently bought Kia Seltos, and if you see MG also, they say the internet car, so everything can be controlled, by the cell phone, so I can control it with my phone, and everything is like right from the seat control to the cooling and the tire monitoring, everything can be done, and there are a lot of software embedded, and that complexity of software is increasing day by day. So how you can ensure that you do a model-based control engineering, how you can ensure that you can have a verification and validation of this embedded software code upfront, so that also can be done across, and all this business solutions can help you manage that. Let me show you what we can do it across. So when you talk about that, the solution here is your application lifecycle management, which can capture not only right from the requirement rather. So it can capture your software requirements. It can capture, what was the code which was written for that, or what was the architecture, your code which was written for it, what was the use case, what was the test case, what was the test results, and then what was the binary, and this particular binary has gone into which variant of your vehicle. And you can do a complete traceability top down, right from your requirement to the binary, and backward also from binary to the requirement. In case of any failure, you can always trace down, either backward or forward, to ensure that there is a complete, the system is complete auditable and maintains the industry standards. So you can define your complete architecture, you can do your complete software integration, as I was talking about. You can do your entire development of the software, of that, and then whatever tools you're using for your testing, you can very well manage that. So in a nutshell, if you ask about, so this is apart from your CAD modeling, apart from your PLM, which were used in the past or in the last decade, so ALM is one which is picking up quite fast, wherein what you see in the inner circle, what we talked about, from your requirement, from your coding, from the variant management, the test cases, it can be managed, whereas it is also integrated with all the tools which the software developer uses, whether it is Eclipse for as your IDE, integrated development environment, or whether you're using Vector or your LDRA for your test code coverage, or you're using some other standards like it can be very well integrated with any PLM. In our case, it is Team Center, or any system modeling tool like Magic, or for all the hardware and simulation, you can integrate with all the simulation tools from our Sim Center portfolio. So that's that helps to manage your complete software, which is an important part in today's vehicle, which goes into your vehicle. So the third important aspect is your attribute optimization. So let's see about across, what happens, So the challenge here is that how can you manage your energy consumption, and how can you do not only manage that, how you can do that consumption analysis at each step, how you can ensure your thermal packaging, and what should be the control strategies for that, how you can ensure, that your voice or your vehicle noise level and the vibration is optimized upfront in the virtual world itself, can be done across. So this basically talks about how your systems, or how your attributes like battery pack, cooling, and this is in case of electric vehicles, electric motors, your HVAC, and we'll come across on the HVAC also in the next couple of slides. Your control system and electronics can be balanced and optimized so that, from an end user perspective, you can achieve your range or your driving range. You can ensure that the vehicle is reliable. You can ensure that the noise vibration in harness is under control and the thermal management of the vehicle is under control. So you can do this also multi-attribute balancing upfront at the design and simulation stage of the vehicle itself. Now, in case of electric vehicle, right, people say that, okay, they are very silent, right? But when the engine becomes silent, right, what happens is, in case of IC engine, the IC engine noise used to mask, all the wind noises, which was coming just because of the rear view mirrors, the side mirrors, basically, which you have on the vehicles, the noise which used to come from road and all. But in case of electric vehicles, all those noise might start coming in. So how you can ensure that, the NVH of your vehicle is still good across. And then what happens in electric vehicle, another is that there's a humming sound, which comes across, which might be very irritating to the passenger. How you can ensure that that is masked. And you need to also induce noise, a warning noise, which should not be scaring the passengers, but which can at least tell the pedestrians, while crossing at the signals, that there is a vehicle which is running. So this becomes again a very important aspect, and which all the OEMs are looking across, the vehicle NVH and acoustic in case of electric vehicles. So this is again a case study wherein this is an European OEM, which did a lot of simultaneously rather complex multi-domain analysis, because it was a hybrid vehicle using our 1D simulation. So they did how the battery behavior simulation, as well as for the IC engine analysis, and how they can be done co simulations can be done, to arrive at some decision, to how to optimize that particular vehicle. So this is one example. Now, as Siemens, we recently acquired another company called Tyres, and through that, we are into safety systems. So when we say safety systems, we are into passive. When I say passive, it is all your how your airbags will get inflated, how your side airbags can do work, and how your seat belts will work across. And when I say active, so we help companies, to ensure that where you can put your sensors, while designing the architecture of a vehicle, so that your vehicle to vehicle, your vehicle to infrastructure, all those communications can be very helpful, in case if you're going into ADAS. And as one of the panelists also mentioned, autonomous is still way away, but what India has already started, and the world across has started a big investment in ADAS, which is your advanced driver assistance system, which can help a driver, to be driving in a very safe manner, and be also safe, from the passenger as well as the other vehicles, from safety perspective. So that is there. Plus, apart from that, we have our own complete independent test facility, which is in Netherlands, wherein we take the vehicle, do a crash, collect the parameters, send it back to the OEM, and tell them, how the vehicle has been performed as designed, or what were the loopholes and across. So that facility is also there. Of course, the vehicle doesn't come back. Okay. So then comes about the vehicle engineering. Of course, which was talking about is that electric vehicle is simple, but again, if you are going with electric, or if you're going with a mild hybrid, or if you're going with plug-in hybrid, then the vehicle engineering and the vehicle integration becomes slightly complex, because you need to take into consideration your space, your weight, and also you need to ensure that your complexity of the vehicle is also optimized. So these are the three factors, which you should carry about across. Now, why we say about weight, so people talk about battery. You talked about battery, and then apart from battery, the most power, the next weight is taken by wires, and the wire is again contributes a lot to the weight of the vehicle. So that you need to reduce it across, and then of course the other independent systems, which you need to do across. So this all architecture can be done, all your systems with the different system can be upfront validated using the mathematical model of this particular systems, through 1D. So whether it is your control systems, your electric motors, your engines and battery, so that you can also, and some of the companies which have launched or which have opened their manufacturing centers in India, they also use it to ensure that how much they can localize the system in India without compromising on the safety and the performance. So that all simulations can be done upfront before even selecting your tier 1 or tier 2 suppliers. So what we again recommend is basically in case of also electric vehicles to follow you should capture the product requirements, and you should follow an RFLP process, which is you should have your requirement at the product line level, which should be broken into your systems and the subsystems. You should convert that systems requirement to different functional and the logical systems, and then you should go across and do your design, your physical part or your physical BOM, across. And when I say physical, it is again the 3D model, not the real physical stuff. So their complete RFLP process should be put into place, and you should ensure that whatever you are doing your future modeling, you should do all your attribute management upfront. You can play across and ensure that upfront how much variance or how many configurations you can do upfront and still meet the product target, which might have been defined either as per the regulation or as per the customer, for whom you're catering to. So this particular talks about how this integrated system looks about. So right from your customer needs, how you translate that customer needs into your technical requirements, and how you bring your quality function deployment or QFD still implies, and those are the frameworks which are still applicable. The technology not, but the framework is still applicable, whether it is IC engine or electric vehicles. And then you can convert that, and you can use that to do your multi-model design and your simulation of that, and ensure that how the different system works, and all those compatibility issues can be upfront validated and verified. And then you go for your digital manufacturing. So all those seamless flow of the data, and one of the panelists mentioned about the digital twin world, so how your digital product twin can talk to your digital plant twin, and then to the real world, the real where the manufacturing is happening and the digital utilization. So all this has to be seamlessly integrated and closed loop, so that once the vehicle is rolled out, the feedback comes back to your product engineering or to the R&D and to the manufacturing, so that the product can be further optimized. So that was about that. And then let's touch upon the electrical systems. So as we were talking about, and this is one of the electrical wire harness architecture of a vehicle, of a car. So if you see that electrical systems are also growing very, very fast into the vehicle. And then as I was mentioning, apart from the electric, apart from the battery and the electric powertrain, it is the wire which also adds a lot of weight, So how you can ensure that it is reduced. And so if you see, this is one of the critical aspects of one of the electric cars. So there are multiple radars, there are multiple cameras. You can get now a 360 view of your vehicle. There are multiple sensors, there are multiple motors. Whether you want to automatically control your seats or your mirrors or even your window panes. So multiple ECUs, multiple electrical signals. There's a mixed voltage dynamic happening. So the vehicle will be having right from 12 volts, 28 volts to 115 volts. Now, so this all will add to weight. But another important aspect here is the cost, right? Because remember, this wires which are flowing in the vehicle is made of copper, and copper is a costly material compared to other stuff. So how you can reduce the cost and increase the design quality, and also decrease the weight of the wires, so that the overall vehicle weight can get reduced, can also be simulated and can be done upfront. And what is required for that is a model-based approach, generative engineering, and a connected environment, wherein your mechanical tab is tightly integrated with your electrical tab, and also that all is integrated very tightly with your product lifecycle management tool or the ALM tool, so that you can very well simulate the entire scenario and see it upfront. So then the last part, or the second last part, is basically about the electric powertrain, which we will talk about now. Is so if you see in the electric powertrain perspective, So you have your drive electrification, plus you had one of the panelists, I think Suresh from Minda, mentioned about the power electronics also, right? So when you talk about the drive electrification, you need to ensure that you need to solve this multi-physics problem, and with the tools now, especially from our sim center portfolio, for Start CCM and all, you can very well do this multi-physics simulation and ensure that you get a very right product. But when you talk about power electronics, they put a challenge about endurance and the thermal challenges, of the power electronics, because they should not also fail, so how you can do those thermal simulation and ensure that the heat doesn't build up, and there is no chances of failure in this power electronic components can also be done across. So this all can be done, this all can be very much simulated to ensure that you get a more optimized performance and the life and the thermal management of the vehicle. This is one of the examples of one of the Japanese companies who used our Motosolve solution, and this was particularly used to enable, how they can do upfront in the virtual environment than the analysis of this electric motor, and so it was done, through this particular solution, and we ensure that you can replicate easily the windings which goes into your electric motors. You can do all the electromagnetic and thermal analysis upfront, and then you can do all those by all those experiments upfront virtually. You can do it across. So this is one of the case studies from this company. Now that was about all the 6 issues, but all this can be managed across on a single platform, which is Teamcenter in our case. And this is some of the solutions from electric powertrain, which we do across, which is which is from the Siemens Mobility business unit. These are again zero emission, of course, because it's all electrical motors. They are all very quieter, and they're all emission free, and they're all very much future proven and proven technologies. Then this was about the Volvo car, which I showed a case across, the C30 electric motor, which is used in this vehicle, which is again used by Siemens employees in the form of shared mobility in Europe. And this is the Vinia bus, which wherein rather than having a diesel or a gas-driven buses, so the whole power requirement, was reduced by 25% by using electric motors and the design from Siemens in this buses which runs in the capital of Australia. So if I have to summarize, so again, any questions on any of these factors, whether battery design, software control, attribute, vehicle, electrical powertrain, or electrical systems, just put down on your chat window, and then I'll see how I can answer that, or do an individual reply, or can answer you, or me and Dr. Mani can answer that at the end of the session. So if I have to summarize, with the battery design manufacturing, there are solutions which are already available, right from the chemistry, packaging, charging, and thermal. The complete battery management system is there to do those entire simulation. And of course, there are solutions, with regards to manufacturing and also your charging stations, whether it is the complete charging station or also the mating part of your charging station. Then we touched upon on the software controls, how you can have a completely model-based embedded software design studio, and how you can ensure that your software requirements and your software bill of material is also integrated with your mechanical, your electrical, and mechatronic components. So that as a product manager or as an R&D head, if I want to see the complete vehicle bill of material, I can very well see that with a seamless integration of my PLM and ALM solutions. Then we saw, or we touched upon the attribute optimization, wherein we saw that how you can do not only your energy management and thermal management, how you can do your complete noise, vibration, and harness stuff, how you can ensure that your drivability and aerodynamics still remains intact, and also the safety issues can be also addressed. Then the vehicle engineering, we talked about how you can do your lightweighting. Of course, you can do the lightweighting of the vehicle by using composites, which I think Amitabh or somebody mentioned, by using composites, and fibers and other stuff without compromising on the safety aspects. So that is one important aspect, which you can do across, and we work with companies like Unity in Sweden and others, to do that. And then, of course, how you can do their packaging, your vehicle dynamics, to ensure that driver comfort is still maintained. And then we talked about the electrical system, because there are multiple voltage carrying stuff. There are a lot of electrical wires, which goes across in your vehicle, which adds to weight as well as your cost because of the copper content, how you can do your complete EMI and EMCs. And we can have a detailed session on each of these topics. And this solution, which we offer it across, is through our mentor portfolio, which the tool is called as Capital. And then, of course, your electric powertrain. So we have a lot of solutions wherein you can do your motor design. You can optimize your motor design upfront using our design exploration tools. You can do your complete electric powertrain and your thermal management. And of course, all this has to be put into a continuous verification and validation framework, which is the V cycle, which is a standard, which is a system engineering standard, which is governed by INCOS. So we do follow that, in any kind of vehicle development. So by this, you can maintain all your systems, whether it is chassis, body, powertrain, electric and electronic components, or your complete vehicle integrations, to ensure that from you can provide to your passenger the best fuel economy, the energy management, drivability, and comfort, ensuring that cabin is comfortable, from the noise or the NVH perspective. So all this has to be, integrated. So any startup, you can start on an integrated platform and stay integrated, so that that value chain and the feedback loop is also closed. That's my last slide. So thank you, to listening to me. I think it was fast because I was allocated a 30 minutes time to do it across. But for each of this, we have a small deep dive session on each of these topics on 23rd of June. So I request you humbly to join those sessions to go into deep dive. And otherwise, if you want to have a one-to-one sessions, you can just drop me a mail. I love to talk about, in each of this, and pull up my expert also to do that. Thank you.
Thank you, Mr. Rakesh, for a very insightful presentation, and very beautifully constructed one too. And we have a few questions from our attendees, if I may ask them ahead for them. Right. So one question that we have is regarding the concept of ultra capacitance and how it can be incorporated better into the EV industry at the present the present scenario.
This is actually a question which probably I would have to do a little bit of research and get back. So if you could please get the details of the person that asked the question, I will work on it and get back to
Sure.
the
this particular question has been asked by Mr. Adam Trivedi. We will share the details with you later. Right. Moving on. There's another question we have, which is regarding the legality side of things, which is, does the panel think a mandate for EVs is a must for higher adoption, particularly with the 2050 IPCC net zero limit?
I have to check about it now on this particular standards to do across, because we have been, I don't know, we just follow the emission stuff, and from the safety standards, whatever is defined by the automotive standards like AutoSAR or ISO 26262 and others. From emission, I'll just check across, so just
Right.
You can.
Sure thing. So actually, all our questions here are really detailed and would require elaborate answers. So what we're going to do is we're going to have you given the details, and you can reach out to our askers directly.
Sure.
And on that note, I would like to thank all our attendees and all the panelists who were present with us before and who are present with us now, Mr. Rakesh Pandey from Siemens as well. Thank you so much for your time, gentlemen. I hope that it has been as insightful a session for the attendees as it has for the ET team here. And yeah, on behalf of the editorial team at ETAuto, please stay tuned. Please tune into our other sessions also. And have a great day ahead. Stay home and stay safe. Thank you.